There's a cell in your skin right now that won't die. It can't divide, it can't do its job, but it won't leave. So it just sits there, leaking poison, dissolving your collagen, turning the cells next to it into more of itself. We call them zombie cells, and the older you get, the more of them you've got. So today, I'm going to walk you through what these cells actually are, why your skin makes them, exactly how they age your face, and what the research now says about clearing them out. I'll tell you about the class of compounds, some of them already sitting on supplement shelves, that can selectively kill these cells. More specific later, names, doses, what the human trials actually show. Stay with me because I think the honest version is more interesting than the hype. Chapter 1. What a zombie cell actually is. Let me start with a normal cell because the contrast is the whole point here. A healthy cell grows, does its job, and divides to make new cells. When it gets old or damaged, it dies in a controlled, tidy way, a process we call apoptosis. It dismantles itself, and your immune system clears the debris. No inflammation, no collateral damage. Senescent cell breaks that contract. Senescent just means it has permanently exited the cell cycle. It can't divide again. It stops dividing and it locks itself in place. But it does not die. It resists apoptosis. It stays metabolically active, sometimes for years. And that refusal to die is the whole problem here. It also doesn't go quietly. It switches into a pro-inflammatory state and starts secreting a toxic cocktail. Molecules that inflame your tissue, enzymes that degrade your structural proteins, and signals that stress the surrounding cells. I think of it as a cell that's decided to take the whole neighborhood down with it. Chapter 2. Why a cell turns. Your cells don't go senescent at random. Something has to trigger it. The classic trigger is telomere shortening. Your chromosomes have protective caps on their ends called telomeres. Picture the little tips on a shoelace. Every time one of your cells divides, those caps lose a bit of length. After roughly 50 to 70 divisions, what we call the Hayflick limit, they're too short to protect the DNA, and the cell gets the hard stop signals. No more dividing. And this is, by design, one of your body's cancer prevention systems. A cell that keeps dividing with damaged DNA can become a tumor cell. Senescence pulls the emergency brake first. But telomeres aren't your only trigger. UV exposure does it, so does oxidative stress, the cumulative damage from reactive molecules, basically internal rust. And so does any serious DNA damage. In each case, your cell makes the same call. Something's wrong. Shut down division. Lock it down. So early in your life, this system is protecting you. The trouble shows up later. Senescent cells accumulate over the years, and your body gets less able to remove them. Which brings me to why they do so much damage. Chapter 3. The SASP. The poison cloud. Here's a key idea, and I want you to slow down with me for a second. The damage isn't really about the cell failing to divide, it's about what it secretes. Your senescent cells release a defined set of molecules that we call SASP. That stands for the senescence associated secretory phenotype. I want you to picture a poison cloud with 3 kinds of ingredients. First, inflammatory signals such as cytokines, interleukin 6 and interleukin 1. Cytokines are the molecules your cells use to talk to each other. These particular ones are broadcasting emergency, switching on inflammation in the surrounding tissue. Second, matrix degrading enzymes. The matrix metalloproteinases, MMP9 and MMP12 among them. These cut through your collagen and the other structural proteins that hold your skin together. Third, growth and signaling factors can push your healthy neighboring cells into senescence too. So, one zombie cell is never an isolated problem for you. It spreads, it recruits, it manufactures more zombies out of your healthy cells. And that poison cloud grows right along with them. And this is a big reason your skin can feel chronically inflamed as you age, even when you haven't irritated it with anything. The inflammation is coming from inside your own tissue. I have a genuine question now, and I want you to actually answer it below. How many of you have always assumed that reactive, irritated skin comes from something you put on it? because much of it comes from within. Tell me in the comments, does that change how you think about your own skin? Now, when you're young, your immune system finds and clears these cells pretty efficiently. But your immune surveillance declines as you age. We call that immune senescence. So the zombies start outpacing your cleanup crew, the SASP keeps flowing, and the damage compounds year after year. Chapter 4. What it looks like on your face. So how does all of this show up when you look in the mirror? When senescent cells build up in your dermis, you get a pattern I think you'll recognize. Thinning. Those MMP enzymes break your collagen down faster than your fibroblasts can rebuild it. So your dermis loses density and structure. Slower healing. Your senescent fibroblasts, the cells that make your collagen, just don't perform. So your small cuts and irritations take longer to heal. Reactivity. If your skin flushes and irritates easily and stays irritated, that's the SASP keeping a constant low simmering of inflammation going. Loss of glow and firmness. A thinner dermis plus chronic inflammation is the biology behind that tired, less bouncy look you're trying to fight. Oh, real quick, before the good part, if this is the kind of skin science you want more of, hit like and subscribe. I break down one of these every week, because this is where it gets genuinely exciting for me and where I really want to give you the honest version. Chapter 5. Clearing the zombies. SENOLYTICS. A few years ago, researchers asked the question you're probably asking right now. What if we don't have to live with these cells? What if we could selectively kill them? And that's the idea behind SENOLYTICS. Seno stands for senescent and lytic for break apart. And I love how they work. Your senescent cells survive by leaning hard on anti-death survival pathways. SENOLYTICS briefly knock out those pathways, and the senescent cell, which had been barely holding on, finally undergoes the apoptosis it had been resisting. Your healthy cells, which weren't depending on those pathways, get left alone. Because of that, you can dose SENOLYTICS in short bursts, hit and run, instead of taking them continuously. You clear out a batch of cells, stop, and dose again weeks later. That's a real departure from how we usually think about a supplement. Let me give you the honest landscape here. Chapter 6. The benchmark. DASATINIB plus QUERCETIN. The most studied senolytic isn't a single compound. It's a combination of DASATINIB plus QUERCETIN. DASATINIB is a prescription cancer drug. QUERCETIN is a over-the-counter plant flavonoid you can buy today. They hit different survival pathways, so together they clear a wider range of senescent cells than either one alone. And here's the landmark human data. In 2019, a Mayo Clinic team ran the first in-human pilot in patients with diabetic kidney disease. Just 3 days of oral D plus Q measurably reduced their senescent cell burden, fewer P16 and P21 positive cells in fat and skin within about 11 days. And it lowered their circulating SASP factors, including IL-6 and the MMP enzymes. That was the first direct proof that senolytics actually clear these cells in living people. And for your skin specifically, a 2024 study showed D plus Q applied to aged human skin grafts cleared the senescent dermal fibroblast, suppressed the SASP, and increased collagen density. That's about as on the nose as it gets for what you and I care about. But here's the catch, and I want to be straight with you. The heavy lifting in that combination is arguably DASATINIB, and it's prescription only with real side effects. So the over-the-counter story is more nuanced than just take quercetin. Quercetin is a flavonoid, a plant compound, and you'll find it in onions, apples, berries, capers, and green tea. On its own, I tell you, it's a fairly weak senolytic, but it's accessible, well-tolerated, and has broader anti-inflammatory and antioxidant effects. If you're going to take it, the practical details matter, because quercetin is poorly absorbed. Only a fraction of your dose actually reaches your tissues. Take it with a fat-containing meal, which generally improves your uptake. Phytosome and liposomal formulations absorb a lot better, so you can use a lower dose for the same effect. Typical supplement dosing runs around 500 milligrams, and trials have used 500 milligrams twice daily. And senolytic research has leaned towards short, pulsed courses rather than taking it every day forever. Fisetin. Fisetin is the one that a lot of researchers are most excited about as a standalone. It's another flavonoid found in strawberries, apples, and persimmons, and in the 2018 Mayo Clinic study, it emerged as the most potent senolytic among the flavonoids they screened. The headline that grabbed me: when they gave fisetin to already old mice late in life, it extended both their median and maximum lifespan and reduced their senescent cell burden across tissues. The human trials are underway, but not yet fully reported. Mayo's AFFIRM trial is testing pulsed high-dose fisetin for frailty and inflammation. There are trials in peripheral artery disease and a long COVID pilot. So, as of right now, the robust published efficacy data is still in animals, which means I'd call this promising, not proven in people. Typical supplement dosing is around 100 to 200 mg daily, though research protocols use much larger, short pulses. Like quercetin, it's poorly absorbed, so fatty meals and enhanced formulations help you here too. So those compounds I teased at the start, the over-the-counter ones are quercetin and fisetin. The most proven protocol, DASATINIB plus quercetin, is prescription territory. Chapter 7. My honest evidence summary. It's strong and direct in animals. A real human proof of concept for D plus Q, early and incomplete for fisetin and standalone quercetin in people. We don't yet have large long-term human trials showing these supplements visibly rejuvenate your skin or extend your health span. I find the direction exciting, but I won't pretend the certainty is there yet. And here's a caveat. Quercetin and fisetin can interact with your medications. Quercetin affects drug metabolizing enzymes and can raise the levels of certain drugs. If you take any medication regularly, talk to your physician before adding any of these. Remember, they're not magic and they're just one piece of your strategy. So, here's what I genuinely want to know from you. Now that you've seen the data, strong in animals but still early in humans, would you start quercetin or fisetin today? Or wait for the bigger human trials? Tell me below, and tell me why. I read every comment. And for me personally, I have found an interesting combination product. There are definitely some products out there, and I think I want to try them. I have linked some of them down below, and also one made in Europe, my top pick at the moment. Chapter 8. Supporting your skin from the outside. Senolytics are a systemic play. You swallow them, and they circulate through your whole body. But what about your skincare? The honest answer? There's no proven topical senolytic on the market yet. What you do have are ingredients that help your skin withstand the damage while these cells are present. They won't clear your zombies, but they help your tissue hold the line. And most of these actives have been discussed earlier in some of my videos. I will go through them here and also show you some examples of products you can use. Retinoids. I covered these in episode 2. When your senescent cells are degrading your collagen, you want maximum collagen synthesis to compensate. Retinoids turn up exactly that machinery in your fibroblasts. They don't touch the senescent cells, but they help your tissue resist the loss. Niacinamide. It's anti-inflammatory. So, when the SASP is flooding your dermis with inflammatory signals, niacinamide dampens that response for you. It won't clear the cells, but it helps you manage the chronic irritation. Vitamin C. It's an antioxidant and it's a genuine cofactor for collagen synthesis. Your body literally can't build collagen properly without it. Some logic, structural backup for your tissue, while it's under senescent cell stress. So, layer them. Your vitamin C first. Wait a few minutes, then add your niacinamide and apply retinoid at night. You're supporting your skin's ability to maintain itself despite the zombies. Chapter 9. The honest truth. Here's my honest truth for you. You almost certainly have senescent cells accumulating in your skin right now. I'm not saying that to scare you. It's just biology, and it happens to all of us. But I think we are at a real inflection point We understand what these cells do. We have compounds that clear them in animals and in at least one combination in humans. And the field is moving from mouse data into human trials in real time. Within about 5 years, I believe Senolytics could move from supplement shelf curiosities to genuine targeted therapeutics. And that would matter to you, because it means we'd be going after a root driver of your skin aging, not just managing the surface. Here's what I want you to walk away with. You know what zombie cells are. You know the compounds that research is pointing to, and just as important, you know where the evidence is strong and where it's still thin. And you know how to support your skin while the science catches up. One last thing before I let you go. If you want to go even deeper into this, and I mean properly deep, that's exactly what my new membership is for. It's where you and I get to nerd out without holding back. And it's how you directly support the channel so I can keep making these videos. Click join below, right below this video, starting at only $4.99 a month. I'd generally love to have you there. So welcome. Next episode, DNA repair enzymes. How your cells fix damage before it becomes permanent. So, see you there. Bye.